キーノートの開演です。
さて、AWS サミット最終日のテーマはイノベーションでございます。前半、茂木さんの方から脳科学とテクノロジーについてのお話をいただきました。後半はギアをちょっと変えまして、Amazon のイノベーションについて、時間を割きたいと思っております。Amazon の成長の歴史というのはイノベーションの連続です。こちらはジェフ・ベゾスが会社を起こすときに紙のナフキンに書いたですね、事業モデルです。まず企業を成長させていくためには顧客体験、ここがまず非常に重要である。よく我々社内でですね、何を軸に考えるか、常にお客様の満足度を考えて意思決定をするようにということをですね、会社の意思決定の軸に持っております。あっと驚くようなお客様の体験をどうやって作っていくかっていうのをですね、常に我々は模索しながら日々送っております。で、この顧客体験があっと驚くような、皆さんが驚くようなものができればお客さんが集まっていただいて、そこで一緒にビジネスやりたいというパートナー様が増えると。すると品揃えが増えて、またお客様がお喜びいただくと。で、このサイクルをぐるぐるぐるぐる回してきたというのが Amazon の歴史です。で、実は Amazon ウェブサービスというビジネスも全くこれと同じです。当初 AWS ビジネスが世の中に出た11年前ですね、誰もここまで成長するとは思ってなかったんですね。当初デベロッパーの方々に喜んでいただいて、徐々に企業に広まって、今やこれだけのビジネスに成長いたしました。これすべてはいくつかのイノベーションの種から始まっております。で、我々このイノベーションというのは非常に重要視しておりまして、一つ一つのアイデア、これ社員一人一人が持っているアイデアをちゃんと具体的にビジネスにするためのメカニズムというものが会社の中に実は盛り込まれております。いくつか例を挙げますと、一つはですね、プレスリリースというものがあります。例えば我々 AWS に関して話をしますと、新しいサービスを作るときに非常に優秀な技術者が揃ってます。その彼らが作りたい技術を作るんではなくて、作りたいと思ったときにこの技術あるいはサービスが実際にお客様が使われたときに何て言ってくれるだろう、どういったインパクトをお客様に与えられるだろうかということをですね、常に考えます。ですので、何か我々はサービスを作るとき、技術の方が新しいテクノロジーを生み出すときというのはプレスリリースをまず書くところから実は始まります。そうすることによって技術が作りたいものを作るんではなくて、その技術が具体的にお客様に対してどういうインパクトを与えるかというところに焦点を当ててサービス開発をいたします。で、または Amazon には2ピッツァルールというですね、組織の構築のルールがあります。これはピザ2枚を食べられる分ぐらいでチームを作りますと。だいたい10名から14名ぐらいです。これぐらいのチーム運営をしていかないと、これぐらいのチーム運営ですと10人14人の全ての意見を吸い出すことができる。これが20人40人になってしまいますと、役職が大きい方、役職が高い方、あるいは声が大きい方の意見に左右されてしまいます。10人ぐらいの規模ですと、一人一人の方が持っている面白いアイデア、あるいは相手に対しての反論ができる。で、そういった種をですね、そういったところで生まれてくるイノベーションの種というのを我々非常に重要視しております。ですね、我々の社内の会議で非常に面白いのはですね、役職が上であろうが下だろうが真ん中であろうが、誰かが言う意見に対してチャレンジをしていくっていう文化があります。そうすることによって別に社歴が長い方、あるいは年がいっている方が言ってることは正しいわけではないと。そういったものを繰り返すことによって我々イノベーションというものを生み出してきました。Amazon のイノベーションを揃えていくと本当にキリがありません。これ代表的なものになります。で、本日は3つのイノベーションについてテーマを絞っております。一つは Amazon のダッシュ&リプレッシュメント。これは Amazon ダッシュボタンというボタン。これは日本でも発売されています。あとは補充サービスもこの Amazon ダッシュのチームがやっております。で、2人目のゲストは Amazon の Alexa です。エコーという AI の音声認識のデバイスの Alexa のチームです。で、3つ目が物流で動いておりますロボティクスですね。この3つの部門のチームから Amazon のイノベーションについてお話をさせていただきたいと思います。それではまずはじめに Amazon ダッシュ DRS のシニアマネージャーでありますクリス・デイビスを紹介したいと思います。
Thank you so much, Nagasaki-san. My name is Chris Davies, and I look after the Dash replenishment business for International, for Amazon, from Seattle. And I'm here to talk to you about the Dash replenishment service and what we like to call the Internet of Useful Things. The Internet of Useful Things is powered by the Internet of Things. And the Internet of Things really is the internetworking of physical devices, sometimes referred to as connected devices or smart devices, that are all around us every day. Our vehicles, our homes, garage door openers, lights, thermostats, and even in the buildings that we occupy every day. There are connected water meters, there are connected electricity meters. Really, IoT can be embedded into any device, but the trick is that the cloud, with functions like Lambda and EC2, are able to drive the capability of IoT devices even further than they were ever able to go before. So what we see is a paradigm shift. The Internet of Things is changing the way we interact with products today. Our customers are changing their interaction models. So we see in the app paradigm, we had click and tap and swipe. Today we see talk and chat and push. Customers love Alexa. They're speaking to her every day, giving us more information about how they operate and what they're using voice for. We used to have monolithic backends, and that forced us to rush to sort of API enablement as well as hardware standardization. But we see in IoT that artificial intelligence and machine learning, event-based interactions, as well as hardware abstraction in the cloud is really leading the charge to change the way our customers interact with our experiences. Now, in the smart home organization in Seattle, we're on the forefront of this work with Alexa, Alexa Skills Service, or excuse me, Alexa Skills Kit, the Alexa Voice Service, the Dash button, and the Dash replenishment service. But we see an opportunity in the Internet of Things. And that opportunity is that really at Amazon, we innovate on behalf of our customers. And it's important to us to create products that leverage the power of IoT to make it really useful. And we call that the Internet of Useful Things. So here we have a couple of tenets that we use to help us think about how to be customer-focused and customer-obsessed with Internet of Useful Things. First, companies must listen and learn from their customers. These devices are connected to the internet. They're using advanced sensors. They have software embedded in them. We should listen and learn from our customers' feedback so that we can enable the second thing on this list, really, which is that smarter products must get better with time. These technologies are allowing us to learn more and more from our customers every day, and our customers have a longer lifespan with our devices. So those devices should be able to become better while they're still in the customer's home. Secure devices must protect customer trust. This is critical for IoT. It's a concern that many consumers have, and rightfully so. We must make sure that we do everything we can to protect customer trust. Everyday activities become simpler. It was not possible for you to say, Alexa, turn on my lights, before we had Alexa and machine learning and natural language understanding. So we see that we can enable things that were not possible before IoT using the Internet of Useful Things. So we see a change in the way customers behave. Now, at Amazon, we've seen how customers choose to shop and what they are looking for throughout our history. Just 20 years ago, we were still browsing on the desktop, right? The mobile revolution happened. We're all using mobile phones today. And so we invented on that concept and created the Dash button. And we call that the direct model. Here on the screen, we have the Enterprise IoT Dash button. With Lambda, this device can be used to do anything, really. So the Dash button is a direct way for customers to have a one-click experience with Amazon.com. The next step is the zero-click experience. And what we see is that customers have so many needs for products in their home, and we believe that the best experience for products in your home, as far as shopping is concerned, is the shopping experience you don't have to have. And so with the Internet of Useful Things and Dash replenishment service, we believe that we can make those shopping experiences disappear. So I put some fun things on the slide here to talk through moments that our customers have that we think the Internet of Useful Things is very powerful at solving. So the first here is the I forgot to add it to the list moment. So you're at the grocery store, you've got your list, you know what you need, but there's something bothering you. There's something you've forgotten, and you know because you laid hands on it before you touched it before you left, right? You get home from the grocery store, and it's milk. You forgot the milk. And you must have milk, so you have to go back to the store to get milk, right? This is a common problem that many of our customers have. The second is the I should replace this moment. This toothbrush is very badly worn, but my problem is I'm never at the grocery store when I notice that my toothbrush is badly worn. I'm always standing in front of my bathroom sink about to brush my teeth. So the idea here is I should replace this device, and getting it onto that list is sometimes very difficult. The oh no moment. This one is fairly self-evident. There are products in our home that we absolutely do not want to run out of, right? And then finally, the I thought I needed this moment. This is where you're at the grocery store and you have your list and you think, I know what it is, it's laundry detergent. And so you grab a laundry detergent and you go home and you open the pantry and there are 7 bottles of laundry detergent, right? So now you have 7 years of laundry detergent available to you because you always somehow remember laundry detergent. So we see these moments as opportunities for the Internet of Useful Things and Dash Replenishment Service to take those intelligent devices and connect them to our open API platform to enable them to manage these experiences for our customers. You don't have to worry about your toothbrush head if your toothbrush is tracking your usage, et cetera. So these are the opportunities we see in the space. So what is the Dash Replenishment Service? What we see is that useful things have intelligence and granular monitoring built in along with connectivity. DRS enables devices that are like this to take that convenience one step further, right? Customers never run out, and they never have too much of a product. And then finally, our goal is to use Amazon Dash Replenishment to open the retail platform to any developer, enabling connected devices and services to place orders on behalf of customers. So these connected devices, like a printer that monitors ink and toner levels that are on board, are allowing their customers, of course, to use those devices. Customers are printing pages, and the devices are reporting to the cloud the status of those things. And DRS enables those devices to place orders for those products on the customer's behalf. So how does Dash work? Well, or how does DRS work? Well, think of a vacuum cleaner. And this vacuum cleaner is IoT enabled. It's connected to the internet. It also has some intelligence on board for the vacuum bag. The vacuum bag also serves as a filter, and perhaps it's monitoring the air quality, or perhaps it's monitoring the volume of debris in the bag. This device communicates to the cloud every time that the vacuum is used, and the user is then sort of able to continue to use the vacuum and not be concerned about what happens when a bag gets too full, right? So when a bag gets too full on a vacuum cleaner, the vacuum's effectiveness may decrease. It may not vacuum as well as it normally would. Also, when a vacuum filter bag is full, the air quality may be degraded as more things pass through that product. And so the customer doesn't want those things to happen. They are incentivized to replace that bag. The vacuum cleaner, in this case, is connected to the cloud and is informing the cloud about the usage. And when the cloud detects that the vacuum bag is near its full capacity, it's able to use the DRS platform and the open APIs we've created to place that order on behalf of the customer. So the customer doesn't even know that they need the vacuum bag. It's just an order is placed automatically on their behalf. And for the customer, that experience is the exact same Amazon experience they expect every day. So that customer gets an order placed email as if they had pressed the button themselves. Then, after the shipping period has elapsed, the product is delivered. The customer opens the box, takes out the new vacuum filter bag, discards the old vacuum filter bag, and places the new vacuum filter bag into the device. And the process continues just like that. This is what we think of with the Internet of Useful Things. This is a vacuum cleaner that's using IoT connectivity to take care of itself effectively. The customer always has exactly what they need. They never have a too full vacuum bag, and they don't have to stock vacuum bags in their own home. Amazon takes care of making sure that they always have what they need exactly when they need it. Now, for developers, our platform is available as an open platform. We have a standard API set that's available, and we use a service called Login with Amazon to handle the customer authentication piece. And I'll be talking more about that in my talk later today. This is some of our DRS partners. We work with hundreds of different vendors, and we learn about new and innovative approaches every day. We're always open to more opportunity, and we think that the opportunity for innovation here is always growing. So in summary, this is a matter of when, not a matter of if. The smart home segment is the largest growing, the fastest growing large vertical in IoT, and it's estimated by ABI that there will be over 600 million devices shipped to customers for smart home in 2021. And that's up from 79 million devices in 2017. This is a huge opportunity for us to continue to grow the space and take advantage of the Internet of Useful Things. We must continue to listen to customer feedback. We have to continue to learn and to process that information and continue to drive innovation in our product creation and development to ensure, again, that the smarter devices continue to get smarter and smarter. Not every connected gadget is actually useful to customers, and so we want to make sure that we are always engaged on creating devices that are eminently useful for all of our customers. And then finally, we want to create products that are not just gadgets, but that leverage the power of the Internet of Useful Things. Thank you.
ありがとうございます。我々にとって今のようなダッシュあるいは補充サービスというのはまだ始まったばっかりだと思っております。製品化することによってお客様の声に耳を傾けることによってもっと我々が想像もできないようなことがおそらくできるようになると思います。膨大なデータをそれをクラウドで処理してあるいは分析することによってお客様の考えるもっと先を我々が新しいアイデアとして提供できるようになるんではないのかなというふうに思っております。それでは2人目のセッションですね。Amazon エコーの肝となるアレクサですね。まだ残念ながら日本ではまだ発売しておりませんが、アメリカでは各家庭にあるぐらい非常に家庭に浸透している音声認識デバイスでございます。エコーですね。で今日はそのアレクサのエヴァンジェリストでありますジェフ・ブランケンバーグを壇上にお呼びしたいと思います。皆さん拍手でお迎えください。
Hello, everyone. So I get the honor of speaking to you about Alexa today. And so we're going to spend a little time talking about Alexa and what you can do and how she works and some of the really cool things that are going on with voice today. So the first thing that I want to talk about is the idea that voice will be everywhere. And we're starting to see this more and more as the technology continues to grow. We have the opportunity to talk to our thermostats. We have the opportunity to talk to our cars. And all of these things are new innovations that give us an opportunity to use our voice, the thing we started, the first communications tool we really had, to be able to talk to our devices. So you see it in cars. You see it in your kitchens with devices like the Echo, but also with all sorts of other things that you can put into your kitchen. And then, of course, smart home is a big part of this as well. The ability for us to be able to talk to all of the connected devices that are in our homes, and instead of having to open an app and push a bunch of buttons, we can just simply say, make this thing happen, and it does. So I want to introduce Alexa a little bit and talk about the devices. We'll start there. There's a number of devices that are available with Alexa on them. You may have heard of the Echo and the Dot and the Tap and the Fire TV. All of these are devices that have Alexa enabled. And I know that they are not available here But what I'm here to talk to you guys about today is actually the idea that you can be building technology for these devices. And so as we go through this and as we talk about the things that I'm going to talk about, I want you to keep that in mind. So what I want to do first is show you a quick video of some of the things that Alexa can do.
Alexa, alarm off. Alexa, what's on the calendar today?
You have 12 events scheduled.
Alexa, call me an Uber.
Your Uber will arrive in 2 minutes.
Alexa, what's the weather like today?
There's a 100% chance of showers.
Alexa, pair my Bluetooth speaker.
Okay, paired.
Alexa, it's time to reorder some paper towels.
Okay, order placed.
And Alexa, play my garage music.
Play your garage playlist from Prime Music.
Alexa, play some jazz.
Playing smooth jazz from Prime Music.
Alexa, who's this?
This is Picnic Basket by Low Tone.
Alexa, turn that up.
Alexa, ask Domino's to send me my last order.
Okay, order placed.
Hey, isn't that Jason Schwartzman?
No, that's not him. I would know if that was him.
I'm pretty sure it's him.
Okay, Alexa, who stars in Mozart in the Jungle?
Stars include Malcolm McDowell, Jason Schwartzman.
Ha! See? I was right.
Alexa, change the bedroom temperature to 65 degrees.
Okay,
Alexa, lights off.
okay.
Alexa, good night.
Good night. Sleep tight.
So that's a little illustration of what Alexa does. Controls your home, organizes your life, manages your calendar. All of these are big, big pieces. So there are two big pieces to the Alexa ecosystem. The first one is on the right-hand side, the Alexa voice service. And what the Alexa voice service allows you to do is take the technology of Alexa and put it in your own devices. So if you build hardware, Raspberry Pi, or you want to build your own toaster, you can do that, and you can put Alexa inside it, and that's what the Alexa voice service provides. I've set it up myself on a Raspberry Pi. It took me about 30 minutes, and I had a fully working Alexa device in my house that I had built myself. On the other side, we have the Alexa Skills Kit. And the Alexa Skills Kit is what enables all of the things that you just saw. The ability to order a pizza, the ability to call for a car. All of these pieces of functionality are built by developers, and those developers can make any technology that they have available to their customers through Alexa. So the way the Alexa Skills Kit works is you build a technology, you write some code that allows your users to be able to interact with your business or your game or whatever it might be. Here's some examples of what people might say to start a skill. You can see I have one that says, ask Skyscanner for a flight to Tokyo. I can book flights. Another one is set the thermostat to 20 degrees if my home is too warm or too hot. Or ask the Guardian for headlines if I just want to get something that's new in the news. These are all examples of what a skill could be. So how do we build these? How do we build a skill? So under the hood, there's a process that we go through to build something like this. As we think about how the technology works and how when someone speaks to a device, how all of this flows, I'm gonna show you that here. So the first thing that happens is you say something to the device, right? Alexa, what time is it? Or Alexa, order me a pizza. And at that point, your voice is translated into text. It moves to the Alexa cloud, where we do something called speech to text, and we take that text and we then take it to an engine we call NLU, or Natural Language Understanding. That NLU engine figures out what you actually meant. If you've ever been in a relationship, you know that what you say is not always what you mean. And so because of that, sometimes, we need to translate that from the words that were said to the actual purpose and meaning. So once you have that natural language understanding, what the user intends to do, you can then take that, and this lands in your code. You have a block of code that handles each of those types of intentions, And your code executes and does the thing that it needs to do. And then once it's done with that, you can respond to the user in one of two ways. The top one here is via voice, right? Alexa says something back to the user. On the other side, though, on the bottom, is the ability to provide what we call a card. And a card in this case is a visual representation of some information or data that you want to provide to the user. So in the example of asking for the weather, you might say, Alexa, what's the weather? And she says the weather today is 30 degrees or 45 degrees or whatever it might be. But on the flip side of that, inside the application, inside the Alexa app on the phone, they can also see things like what the 7-day forecast is, or if it's going to be cloudy or rainy on those days. A bunch of additional information that would be kind of cumbersome for Alexa to say all of those things. She gives you the core information, and then you take that and you can see the rest of it in the app. So that's under the hood. Let's talk about actually building a voice experience. How do we build a skill? Because more than anything, the reason that I'm here talking to you today about Alexa is to let you know that you all can be building skills today. You can all be building interactions with customers today. And so to build one, we start in 3 phases. The first is being able to build a voice experience, and that's what I'm going to walk you through here in the last few minutes that I have, is how do I build a voice experience? What does that look like? The second step of that is writing your code. How do I write the code to connect to my services, to my database, to be able to provide the information the user wants from their requests? And then finally, each skill goes through our certification process, where we actually certify and test your skill to make sure it does what it says it does. And so going through each of those steps is the process, much like building a mobile application, for building your skills. So there's 3 places I really want you to pay attention to. The first one you may not have been to before, but it's developer.amazon.com. And this is where you build your voice interface. This is where you build the plan for how your user is going to interact with your skill. The second one, I think you've all been to before, aws.amazon.com. This is where you can build a Lambda in order to take advantage of our rich serverless ecosystem and allow you to build your skills right in AWS and communicate directly with your voice interface. And then finally, we have a whole slew of tutorials that are available on GitHub. And if you would like to get started or start working through some of this stuff, I'm going to go in more depth this afternoon in my session. But you can also go here to check this out. We have lots and lots of tutorials that are available for you to be able to start from scratch and build your first skill in about an hour. So it's very, very useful information, lots of code and lots of explanation. Okay, so let's talk about what a voice interface looks like, because this is the thing that's new to most people. As we think about building a voice interface, what we're really saying is, what are my users going to say to my code? How are they going to communicate? And that's one of the hardest things to try and figure out is, what are all of the possible things a user could say? Now the nice thing is we can take advantage of the Alexa cloud and take advantage of all of the machine learning and AI that goes on behind the scenes so that we don't have to come up with every possible thing that someone might say. So in this case, all of these things really lead us to, what's the weather? I want to get the weather, please give me the weather. All of those statements really reflect the same intention by our user. So we translate all of those words to the intention get weather, and then we push the user to that get weather interaction. That intent, that get weather, is the pointer to a specific point in our code. Another example of intents would be a DVD player. I think you've probably all used one of these at some point in your lives. And the intents of a DVD player are what you see here on the left. Play, pause, stop, rewind, fast forward. Well, if you had to talk to your DVD player, you might not say fast forward, you might say move forward. You might say start the movie instead of play. All of these are different ways to really get at the same thing, which is my intents, which are play, pause, stop, fast forward, and so on. So by doing this, by creating these intents, each one of those then points directly to my code. And in doing so, then, I can use my code to enact whatever the intent is supposed to do. So if it's supposed to play, then I do whatever code is required to play the movie. If I'm supposed to order you a pizza, though, I should make sure that the code actually orders the user a pizza, because that's the kind of interaction that they're expecting. So finally, and I don't expect you to read the code, I know it's a little small on the screen, the idea is that we have blocks of code in JavaScript that allow you to very easily specify what you're supposed to do. And so I have get me a new fact in this instance, or get me some help. But each one of these represents a block of code. And then we have these this.emit statements. All of these are really meant to do is provide a mechanism for us to be able to communicate with our users. And we do that in one of two ways primarily. The first is a tell. You ask Alexa something, she tells you something back, and that's the end of the conversation. And then an ask is when you ask Alexa for something, and she responds to you and waits for some other response. She's waiting for you to say something again. So that's the core idea behind building a voice user interface, is really thinking about how is my user going to communicate with this? Because it's not going to be the way most of us think about it, which is I'll just take my API and build endpoints for each of the places in my API, and then the user can talk to that. That is how a lot of the bad voice systems that we have today have come to exist. And we're trying to flip it on its side and think about the customer. Think about how is a customer going to interact directly with all of my code. So I want to leave you with one last example of things real people have really built. This is one last video I want to show. It's only about a minute. And it's a video compilation of things people have built with Alexa in their homes. So I'll start that now.
Alexa, kitchen TV on.
Okay.
Alexa, open Sylvia's garage door. Yes, I named my car Sylvia.
Turn off the living room windows.
Alexa, I'm cold.
Your nest is now set to 84.
Alexa, turn on the holiday spirit.
Okay.
Turn on pool deck lights.
Turn on garden lights.
Turn on office fan.
Alexa, turn on coffee maker.
Alexa, ask my house to turn on the vacuum cleaner.
Alexa, pitch ball.
Mix me a Negroni.
Alexa, satellite off. Bam.
All right, so thank you all. This is a little introduction to Alexa, but I hope you guys will join me this afternoon where we're going to talk much more about how you can build some skills with Alexa. Thank you very much.
アレクサの話が今ありましたが、私がアメリカの友人の家に遊びに行った時にアレクサを軸に家族が話してるんですね。で子供が今ありましたけれど、子供が何人かいて、その子供がアレクサにいろんな質問をして、その受け答えをしながら家族で笑ってるみたいな、おそらくそういったものが今後もっと進化していくと思います。で最後のスライドにありましたように、このアレクサというのはスキルはですね、誰でも書くことができる。オープンなんですね。要するに皆さん一つでも二つでもですね、面白いアイデアであるとか、こんなことできないかっていうのをすぐに実行できるっていうのがこの素晴らしさだというふうに思っております。では最後ですね、Amazon ロボティクスです。我々物流が世界にちょっと私も何拠点あるか分かりますが、ものすごい数あります。そこでものすごい数のですね、物流をさばいております。でそこにロボティクスというテクノロジーを我々は今盛り込んでおります。ではここで、Amazon ロボティクスのソフトウェアデベロップメントマネージャーのアンディ・ポラックを紹介したいと思います。皆さん拍手でお迎えください。
Good morning, everyone. My name is Andy Pollack, and I have the honor of telling our story today on behalf of the amazing engineers back in Boston. This is the story of 80,000 robots, all powered by AWS. At Amazon Robotics, our customer is the end user on Amazon.com, placing an order to purchase a product. Could be a college student buying a textbook. It could be a father buying a teddy bear for his little boy. What do? We fulfill orders out of Amazon warehouses. How do we do it? With robots. How do we do it well, fast, and at awesome scale? With AWS. But before we get to that, let's start at the beginning. And let's use borrowing a book from a library as a metaphor for order fulfillment. Let's say I want to go to a library and borrow a book, maybe Harry Potter and the Sorcerer's Stone. I head to the library, and in the card catalog, I find the location information for that book. It may tell me I need to take the elevator up to the second floor, and once I get to the second floor, I need to find the right aisle that the book is in. And once I'm in that aisle, I need to find the right shelf, and once I've found the right shelf, I can pull Harry Potter, and I'm a happy library patron. This works very well for your local library. The library is not too big. The products are all pretty consistent in size and shape. But there's an opportunity for innovation here. And more than just an opportunity, at Amazon, we have a big challenge. We don't just sell books. We sell little things like SD cards. We sell great big things like kayaks. They call Amazon the everything store because we literally sell everything. And we need to get it to you in 2 days, sometimes less. It's a little bit like trying to find a book in a library this big. So with every challenge comes opportunity, and let's seize that opportunity and innovate. What if we flip this problem on its head? Instead of humans walking around, navigating to books, what if I could stand in place as a human, and the books could come to me? As a library patron, my ideal experience, I think I would like to stand in place. I would like to enter the library, stand there, and hold out my hand. And poof, Harry Potter and the Sorcerer's Stone would just fall magically from the sky into my hand. How can we make that happen? How can we make the inventory walk to me? We're going to need some robots. These guys are smart. They are Wi-Fi enabled. They have multiple sets of cameras. They are fast. They move at 1.7 meters per second. And they are strong. They can lift 3,000 pounds all day long. And they need to be strong because they are not just lifting one item at a time. They're lifting a shelf. That's our equivalent of the shelf in the library that we went and walked to, but it's no longer bolted to the floor. It's free. It's moving around. And the fundamental simplification of distributing inventory and making it mobile allows for a graceful ballet of collaboration between humans and robots. In this case, the robot travels to the human who is standing stationary at what we call a station. The pod is presented to them, and they can add new products into the pod for storage. They can pull products out to complete customer orders, and they can perform some inventory quality checks. So I'd like to show you now that you've seen a couple of the components of the system, I'd like to show you a video that illustrates all of these components coming together as a system inside a real Amazon fulfillment center. The video opens inside a truck that has just arrived at the inbound dock, full of products to be stored in the warehouse. Let's imagine that my son Jonah wants a teddy bear. Here's a teddy bear that has just arrived from a seller. It is not yet available for purchase on the Amazon website. The teddy bear has been delivered to a human stow associate to store the product in a pod. The beauty of our system is that it is distributed. Many robots collaborate in a graceful ballet to solve big problems. The pod is being stored in the optimal location, given the products that are on that pod. Once we store it, let's imagine now that I click buy on the Amazon website to purchase this teddy bear for my son. A different robot is dispatched to bring that pod to a human station. Notice many robots queuing up in front of the human station. Again, we want robots accelerating humans. We never want a human to have to wait for a robot. Here, our pick associate takes the teddy bear out of the pod. On its way to the pack lines, the teddy bear will ride along miles of conveyor belt. At the pack line, an associate will put the teddy bear into the right-sized box and tape it up. The shipping label is automatically applied. And we divert the package down the right chute to make sure that it gets on the right truck at the right time. And it will be loaded into a truck. Now, of course, the end result of this is a very happy Amazon customer. This is my son, Jonah. It's pretty cute, I think. I might be biased. But this is the power of robotics. Right? When applied with purpose, we can make little boys happy around the world. So now that you've seen the system in action, you understand the power of using mobile robots to make inventory walk on its own. Let's talk through a simplified version of some of the algorithmic questions we need to answer in software in order to make this system work. So let's take a top-down view and build a virtual fulfillment center. Let's add 4 walls to the outside of the building. Now that we have our building shell, let's pour in some of those yellow fabric pods that we just saw. These are the mobile inventory shelves. Let's pour in a couple of robots in addition to that. And let's store some teddy bears into those pods in the warehouse. Finally, let's sign in just one human pick associate who is available to pick orders for customers. So the stage is set, the teddy bear shall be picked, and the human in the northeast corner shall do the picking. Given this stage, the first question we need to answer is which bear should we pick? You might have noticed that there are multiple copies of the same bear, and that happens a lot in Amazon warehouses. There are some products that are very popular and exist many times, many copies of the same product. So which one of these should we pick? If you're an engineer, you might think first of proximity, because the drive units, the less distance they have to travel as part of their mission, the more efficient we can be overall. So what about this teddy bear that's closest to the human? Well, you might notice one thing that's unique about that one. He's surrounded by pods on all sides. This is what we call a double deep dig out. This means that we have to dispatch 2 robots in order to pick that teddy bear, not just one, meaning that is a more costly mission than any of the other teddy bears in the fulfillment center. Okay, what about the next teddy bear? Again, working by proximity. Well, this teddy bear is technically the same teddy bear as the one that we need to pick, but it is owned by a different seller than I made the purchase from, so we can't pick that one. And finally, let's take a look at these 2 teddy bears. They're pretty consistent in terms of distance from the human station. Which one of these should I pick? One thing I'd like to think about is when that pod containing the teddy bear comes over to me as a human, I would love to pick not just one, maybe 2, 3, 5 things if I could. So we might judge a pod and its fitness for assignment to pick the teddy bear based on what else is on that pod and what other picks we need to execute. So let's pick one that has some other work to do on it. So we've chosen our teddy bear. The next question is which robot will do the heavy lifting? Again, let's work by proximity. Where is there a robot that is close to the teddy bear that we're going to pick? Let's take a look at this one. The first question we should ask ourselves is this drive unit already on a mission? And if so, is that mission more or less important than picking this teddy bear? What about this drive unit here? Does it have enough battery level? Does it have enough charge to complete the mission that we want to assign it? And what about this drive unit all the way up here? Does that drive unit have all of its capabilities? Can that robot move and lift? When did we last hear from this robot? These are some of the factors that go into selecting a robot to allocate to a mission. So let's say we have chosen the teddy bear and we have chosen the robot that's going to do the mission. We need to now plan a path for that robot to get from its current location to pick up the pod and bring it to the human station. Here is one candidate path that we could follow. Just one candidate path. There were no constraints, as I laid that out just now. There's nothing in the way. But in the real world, there are lots of constraints. And those constraints lead to lots of interesting questions. Should traffic flow in just one direction on the highways where the robots are driving, or should it flow in multiple directions? How many lanes should there be on these highways? And what should a robot do if it runs into heavy traffic along the way, if it is congested along that path? So these are complex problems, right? We looked at very small scale, but what if real fulfillment centers were twice as big as that? What if they were 10 times as big as that? What if they were 100 times as big as the virtual fulfillment center that we just looked at? Well, in reality, they are. They are 100 times as big. In a real fulfillment center, we have thousands of humans, not one. We have thousands of robots, not 5. We have tens of thousands of inventory pods, not the roughly 70 that you saw on the last slide. And we have millions of products, not just the one teddy bear that we looked at. How can we possibly solve the problems that we just talked about at this incredibly massive scale? Well, since we're here, the answer should be pretty clear to you. The answer is Amazon Web Services. If you want to go big, you go to the cloud. Now, I should say, we still have some code running on-premise. For example, our robots are functionally safe, and they need to remain functionally safe, even if we lose our connectivity to the cloud. But we have a cloud-first strategy, which means we put as much code as we can into the cloud. And this gives us 3 key advantages. The first is that we can take into account more than just the data we have about this fulfillment center or this zone of a fulfillment center. We can look at the network of fulfillment centers and make different decisions based on that information. The horizontal scalability of Amazon Web Services lets us throw compute at those problems that we talked about earlier. Those problems are hard, and the algorithms that try to solve them take time to converge. Frankly, we don't have time. Right? That teddy bear needs to be on the 5 o'clock truck because we made a promise to the customer that they're going to get that teddy bear on Thursday, and we can't break that promise. And behind that teddy bear, there's a million other products that we need to get out of the building today. So the more compute that we can throw at the problem, the better our algorithms can perform, the more teddy bears we can deliver to happy little boys around the world. And finally, the rolling upgrades and high availability that's provided by AWS means that our engineers don't have to worry about that stuff. We can innovate as fast as our fastest coders can write code, and we can deploy that code as fast as we want with no fulfillment center downtime. That lets us focus on the next big thing. It lets us innovate. Now that we have 80,000 robots running in production, I don't want to minimize the incredible amount of work that goes into manufacturing these guys. That's hard. But from a software perspective, if you want 160,000 robots tomorrow, I'll click around in some AWS web pages. I might have to increase some DynamoDB read-write capacity, but I can get you 160,000 robots. So what's next? AWS has already enabled us to achieve the impossible. So our engineers are busy working on the next big thing. Innovation is core to Amazon's culture. And in his yearly letter to stakeholders, Jeff Bezos describes our relentless hunger for invention with a few simple words. It's still day one. Thank you.
今この Still Day One という言葉が出ましたが、日本語で言うとまだ初日であると。我々毎日この気持ちでビジネスをやっております。ですので最後に話がありましたように、常にお客様のサービスを良くするために時間を使うことができる。その裏には AWS のようなテクノロジーがあるから成し遂げられたと。例えば20年前見てみると、当時ですね、インターネット上で本であるとか洋服を買うというのは誰も想像してなかったと思います。10年前、11年前、Amazon Web サービスが生まれました。その時に10年後の今、数分でサーバーが調達、数分で HPC が調達できるというものをおそらく想像できた人っていうのはなかなかいなかったと思います。それを考えると今ご説明差し上げた3つのサービス、テクノロジーイノベーション、これの数年後、 もう我々の想像を超えたようなですね、価値を我々に生み出してくれるというふうに考えております。で、今日の午後はですね、このイノベーションをテーマにしたブレイクアウトセッションですとかスペシャルセッションを数多く用意しております。本日で AWS サミット最後になりますが、最後の1日は皆様にイノベーションのですね、種を一つでも多く持って帰って、いただきたいというふうに思っております。それでは残り午後ありますが、楽しんで帰ってください。どうもありがとうございました。
以上でキーノートを終了いたします。